Hey, this is lesson 47, graphing functions, page 319 to 325. I'm on the bottom of 319. When we are talking about functions, we're talking about rules that pair one output number with each input number. Okay, so the first things that we need to know when we're talking about the rule or the function with an input and an output are the domain and the range. Now the domain is all the numbers that you can put into the function. That's the input. Okay? And the range are all the numbers that come out in the output. Domain, input, range, output. Okay? That's the first thing that we need to know. We're going to take a look at example 1. Example 1's tricky, and we're not going to spend a lot of time on this because you're not going to see this very much. Okay? Example 1 is going to talk about something called a step function. It's a different kind of a graph. Hopefully I can give you an overview of why it looks the way it looks. So I'll read example number 1 on page 320. It says, the sign at the right describes a function, a rule that relates hours parked to the dollars charged. What is the domain of the function? What is the range of the function? And then graph the function. So the domain would be the number of hours that a car can be parked. Okay. Now a car can be parked anywhere from 0 hours, and if you look, okay, it says that the lot is open from 6 a.m. to 10 p.m., so a maximum of 16 hours. So in that first part, then, we would say that the domain is 0 to 16. And that's hours. Okay. Now the range would be the output. So the domain are the hours on the input. And that's 0 to 16. And then the range would be the price. So what is the range of the function? It says the range is the number of dollars charged for parking for 1 up to for the first hour. And then anytime during the second hour, the charge is $3 plus 2 more. And then anytime during the third hour, the charge is $5, 2 more. And then anytime during the fourth hour, $7, 2 more. And so that's how the pattern continues. And it says the maximum is 15. So our range would be 1, 3, 5, ... until we get to 15. Okay. So why does step function look so strange? Look on the bottom of 320. And in the step function you see a clear circle and a dark circle. So look at 0 on the bottom. It says 0 hours. If we trace 0 hours up, there's no charge, and that's why it's 0. But anything over 0 hours, like 10 minutes, 15 minutes, a half an hour, 3/4 of an hour, will be a charge of $1. Okay? So that's why that whole line is colored in until we get to 1 hour is $1. Now, trace 1 hour up to $3. That's a 0 because it's $1, not anymore. But as soon as you get more than 1 hour, then you start charging automatically $3 until you get to 2 hours, which is exactly $3. That point at 2 over 3 up, you trace up again. Okay, we see the white circle. So that means at $2 or at 2 hours, it's exactly $3. Now, anything over 2 hours, it's automatically $5. So 2 hours, 1 minute is $5. 2 hours, 10 minutes is $5. 2.5 hours are $5. So that's why that whole line is shaded in. And if you look on the very top, okay, we said that the price is capped at $15, and that's when you see that whole solid line capped at 15 hours, and then you see it maxed, or it stops on the x-axis at 16 hours. Okay, so those are our limits of our domain 16 on the x-axis. That's the limit of the range, 15 on the y-axis. Okay. I understand it's kind of tricky, kind of confusing, but we're not going to see a lot of it. I'm going to show you another picture right here of a step function. On this step function, you look at this. Weight in ounces and the cost of the package. So 0 ounces is there's no cost for the package. But anything over 0 ounces right here, it goes all the way to 39. So it doesn't matter if it's a quarter of an ounce, half an ounce, 3/4 of an ounce, 39. When it gets to 1 ounce, it's 39. It's not 41. But anything over 40, or anything over 1 is 41 cents. 1 1/2, 1 3/4, 1 5/8, whatever it is. When we get to 2, it's exactly 41. Now anything over 2 ounces will be 43 cents. And anything over 3 ounces is 45. And anything over 4, okay? So this is what we mean when we talk about step function. The opposite of step function is called continuous function. And continuous function is just a straight line. And that's kind of like that traditional graph that we're looking at. I'm on example 2, okay, for continuous function. That says consider the function p equals 4s. So we're going to say p perimeter equals 4 times the side. Alright, that makes sense? Okay. It says what is the domain for part A? So the domain can't be 0 because we have to have a side length, and it can't be negative. So the domain is all positive real numbers. The range, that's the output, would be 4 times that, and that would also be all real positive numbers. In example 2, part C, it says create a table. So we're going to create a table that says sides and perimeter. So I'm going to say if I have a side of 1, I have a perimeter of 4. If I have a side of 2, I have a perimeter of 8. If I have a side of 3, I have a perimeter of 12. Okay? And then graphing the function. Just going to put a real rough graph on here. Looks like this. Looks like this. And we'll put a couple little, oops. Put a little couple marks on here. 1, 2, 3, 4, 5, 6. X-axis negative, -1, -2, -3, -4, -5, -6. Y-axis positive, +1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7. I think I'll put a couple more up here, just so I'll have enough for a line. Okay. So first point, 1/4 up. We should have a mark right there. And then the next point, 2/8 up, 2/8 up. Right there. And then we can go ahead and connect this line to those 2 points. It's the graph of the function. Now, we say that this graph is a continuous function. And the reason we say that it's a continuous function is because this graph has aligned points and it goes through the origin. Remember, proportional also goes through the origin. Continuous function, aligned points through the origin. I'm going to stop there, and then I'm going to come back and do example 3.